So this is a quick review of different levels of reproductive isolations. I want you to take a moment and refer to your textbook and the lecture notes, and please send me any questions you might have. After you have done so, I would like you to quickly make a list of the main types of speciation and try to come up with an example for each of them. Once you did so, please continue with this video. So the most commonly encountered and probably most easier to understand case scenario of speciation is probably the allopatric speciation. As you remember, it's caused by a geographical barrier preventing interbreeding of two populations of the same species. Given enough time, these two populations can separate far enough through mutation, natural selection, and genetic drift that when given the opportunity to meet again, they do not recognize each other of the same species at different level of reproductive isolation. So the geographical barrier or the physical barrier, it doesn't have to be natural, you'll see in a moment, will interrupt the gene flow between the two populations. That will lead to genetic divergence, which will eventually lead to speciation. So one really good example and very interesting, it's the case of these snapping shrimps that are populated in the two sides of the Isthmus of Panama, which was created about 4 million years ago when Southern America or South America slammed into Central America. As you know, South America was part of Gondwana land, so this southern giant continent that was attaching or was made of South America, Africa, and Australia. And we know that because we already discussed the three species of birds, such as rhea and ostrich and emu, that are similar, but they populate today these three different continents separated by large oceans, which are large geographical barriers. So let's go back to this shrimp. Maybe not. First, I want you to think of other examples. So other geographical barriers could be rivers, mountain ranges, or glacial retreat. So a river can change course after a big storm, or a big storm can move some mountains and block the river flow, so it will change course, which will separate different populations. Or a mountain can arise, or as we mentioned earlier, glacial retreat. So I want you to also think of man-made structures. So turn the video off and think of some examples and then come back. Now that you thought about it, so some examples would be highways or dams, and they are both detrimental to natural populations. And now there are actually some dams have been taken down and allow, for example, salmon populations to come back upstream to rivers that were not flowing but only controlled for decades or probably more. And then highways are a major problem, especially to larger species that need to meet and mate on the two sides of this particular man-made geographical barrier. So back to the snapping shrimp, very interesting example. So even though they were probably the same species before the two Americas were fused through this land mass that we call now the Isthmus of Panama, through, again, mutation, natural selection, and genetic drift, one of the two species, let's say the one in the Atlantic, Alpheus newtongii, was developed this larger right pincher, while the other one in the Pacific, Alpheus milsei, developed the left pincher. So now, if we allow them to meet, so not just through the Canal of Panama, but if you put these two together in the same aquarium, they will not recognize each other because of the different behavioral separation. So even though morphologically they look to be separated mechanically, through mechanical isolation, it turns out that actually it's also behavioral isolation. Another very good example of allopatric speciation, it's from archipelagos, so the classical example of Darwinian finches. And you also have this great example in your textbook about the honey creepers in Hawaii. So please click on this link and read your textbook and then come back. Once you come back, you realize that from this one species that you can see here on the bottom of your screen, so from this one species that arrived probably from mainland, probably from South America, so many different species have adapted to varied type of feeding in particular. So you can see in the top here, you can see a very hard beak that probably is adapted to cracking hard seeds, but you can see right here a much longer beak that is probably adapted to digging for nectar or larvae and so on.